Nevada's lithium isn't a secret anymore. Everyone's heard of Thacker Pass by now. The mine, the protests, the billions in government loans, the General Motors deal. What almost nobody knows is why that one specific patch of desert turned out richer than the rest of an enormous ancient volcano sitting right next to it. And scientists only actually figured out the chemistry behind that difference in 2023. The McDermott caldera straddles the Nevada-Oregon border, a crater roughly 28 miles long and 22 miles wide, left behind after a supervolcano erupted there about 16.5 million years ago, part of the same chain of eruptions tied to the Yellowstone hotspot as it slowly migrated across the region over millions of years, propagating southeast from an earlier eruptive center at Steens Mountain in Oregon. That single eruption released something like 1,000 cubic kilometers of magma, an alkaline mix rich in sodium, potassium, lithium, chlorine, and boron, which cooled almost instantly into glassy volcanic rock called ignimbrite, rock that started weathering and breaking down into fine mineral particles almost as soon as it settled across the newly formed crater floor. A lake formed inside the collapsed crater afterward, and stuck around for hundreds of thousands of years, slowly filling with volcanic ash and eroded material washing down from the surrounding drainage basin, all of it settling layer by layer into thick clay-rich lakebed sediment across the entire basin floor, sediments that would eventually harden into the clay stones sitting under the desert today. That clay held lithium everywhere across the caldera, but not in equal amounts. And for a long time, nobody could fully explain why one part of the basin ran so much richer than the rest. Most of the sediment turned into an ordinary clay mineral called smectite, the same kind found in other lithium clay deposits across Nevada and the American West, typically holding somewhere around 0.4% lithium by weight, useful in an industrial sense but nothing extraordinary by the standards of the resource industry. In the southern end of the caldera, at a site called Thacker Pass, something different happened to that same original clay. A separate mineral called illite showed up instead of ordinary smectite, holding on 1 3/10 to 2 4/10% lithium by weight, roughly double what the ordinary smectite clay carries just a short drive away in exactly the same basin, under what looks from the surface like identical desert terrain. For years, researchers simply assumed illite existed at depth, more or less everywhere across the caldera, one uniform layer sitting beneath the smectite the whole way across the basin, a fairly ordinary geologic assumption that nobody had specifically gone looking to disprove. A team of geologists from Lithium Americas, GNS Science, and Oregon State University published research in the journal Science Advances in 2023 that overturned that assumption directly, based on years of drilling data and detailed mineral analysis most previous researchers hadn't had access to. Their fieldwork showed the illite at Thacker Pass wasn't part of some caldera-wide blanket layer at all, uniform and predictable everywhere you drilled. It formed instead through a second, entirely separate event, after the original lake sediments had already settled and hardened, when renewed volcanic activity pushed the center of the caldera upward, creating the Montana mountains and opening fresh fractures through rock that had been sitting quietly undisturbed for who knows how long before that. Hot hydrothermal fluid moved up through those new fractures specifically beneath the southern part of the basin, and nowhere else across the wider caldera, converting the ordinary lithium-bearing smectite into potassium-rich illite as it passed through the rock, concentrating the lithium into a layer roughly 100 feet thick in the process. That two-step history, ordinary lake clay first, then a second hydrothermal event, that only reached one particular corner of the crater to decades or millions of years later, is the entire reason Thacker Pass turned out richer than the rest of the caldera, and richer than other American lithium clay deposits people already knew about long before anyone drilled Nevada seriously. The illite concentrate at Thacker Pass runs roughly twice the lithium concentration of clay mined at Hector, California, and about 3 times the concentration found in Clayton Valley, Nevada, the state's only currently operating lithium mine, which supplies less than 2% of global lithium demand on its own, despite decades of production. None of that difference shows up if you're just looking at a satellite map of the caldera's outline from above, one flat basin that looks geologically identical from edge to edge. It only shows up once you understand that one specific spot got hit by hydrothermal fluid moving through fractures that simply never opened up anywhere else in the same basin. Lithium Americas began drilling Thacker Pass in earnest starting around 2017, and that exploration program confirmed the lithium-enriched interval ran laterally across most of the southern basin, rather than sitting in some small, isolated pocket easy to dismiss, which is part of why total resource estimates for the caldera kept climbing year after year as more core samples came back from the lab. Earlier assessments had pegged total American lithium resources at around 18 million tons, and newer estimates for McDermott alone now run 20 to 40 million metric tons, potentially making the caldera the single largest known lithium deposit anywhere on Earth, ahead of even the massive brine resources sitting under Bolivia's salt flats. None of that oil and gas style story of a single lucky well applies here, though, since this isn't a story about a hidden pocket and nobody had drilled yet. This is a mineral that had been sitting in plain sight the entire time, mapped and sampled for years by multiple research teams, waiting on chemistry nobody had properly explained yet, rather than waiting on anyone to actually find it in the first place. Getting that lithium out of the ground is its own separate problem entirely, because nobody had ever mined a claystone lithium deposit at commercial scale anywhere in the world before Thacker Pass came along. Lithium normally comes from hard rock spodumene mines in places like Australia, or from evaporating brine ponds across South American salt flats, and clay-hosted lithium had been considered a genuine unknown for years. Technically interesting on paper, but commercially unproven at any real industrial scale anywhere on the planet. A recurring objection investors and engineers both raised for the better part of 2 decades before ground actually broke at the site. Thacker Pass will use hydraulic shovels to dig the soft claystone out of a shallow open pit less than 400 feet deep, with minimal blasting required given how soft the material actually is compared to conventional hard rock ore. The clay then gets processed through a leaching circuit using sulfuric acid produced at an on-site acid plant built specifically for the project, converting the lithium-bearing clay into battery-grade lithium carbonate through a sequence of leaching, purification, and crystallization steps that had never been run together at industrial scale before this specific project came along and tried it. Thacker Pass sits only on the Nevada side of the state line, in the southern part of the caldera, but the same lithium-rich lakebed sediment extends north across the border into Oregon as well, where a separate company called Jindali Resources has been exploring a similarly large deposit for years without yet proposing an actual mine. Whether that northern section holds the same illite-rich layer that makes Thacker Pass so much more concentrated, or whether it's mostly the more ordinary smectite clay found elsewhere in the basin, is still an open question that depends entirely on whether the same hydrothermal fluid pathway reached that far north during the caldera's later uplift. That's not a small detail. It's the difference between an ordinary lithium clay deposit and one that could rival or exceed Thacker Pass itself. And right now, nobody has drilled enough of the Oregon side to know which one it actually is. None of this happened quickly or cheaply on the Nevada side, and none of it is finished yet either. The U.S. Department of Energy committed $2.26 billion in loan guarantees to the project, one of the largest federal commitments ever made to a single domestic mining operation, and General Motors invested $650 million for a 38% ownership stake, along with a guaranteed supply agreement locking in battery material for its own electric vehicles for years to come. As of the most recent construction updates, the site is targeting mechanical completion by the end of 2026, with commissioning running through 2027 and commercial production beginning sometime in 2028, a timeline that keeps shifting slightly the way any project this size and this genuinely novel tends to slip as construction actually gets underway on the ground. Fort McDermott Paiute and Shoshone tribal members, along with environmental groups, have raised ongoing concerns throughout the process about the mine's effect on sacred land, water use, and wildlife habitat across the surrounding high desert, concerns that remain very much part of the project's story, even as construction continues to move forward toward that 2028 target. Lithium Americas has said the operation is designed as a zero liquid discharge facility with a high recycle rate meant to avoid releasing industrial wastewater into the surrounding watershed, and the on-site sulfuric acid plant is designed to generate its own carbon-free steam and power as a byproduct of acid production, reducing the number of trucks needed to haul acid in from elsewhere. Whether those design choices satisfy the concerns raised by tribal members and environmental groups is a separate question from the geology itself, and one that will keep playing out well past the mine's eventual opening. The lake that filled this caldera 16 million years ago had no idea it was setting up a resource fight for the next century when it started laying down ordinary mud on the crater floor. It just sat there depositing clay for a few 100,000 years, then got interrupted by a second geologic event that happened to concentrate lithium in one particular corner of the basin, instead of spreading it evenly everywhere the way the first lake sediments had. Scientists only worked out exactly why that happened in 2023. More than 5 years after drilling had already confirmed the resource was there and worth pursuing regardless of the underlying explanation. Sometimes the ground gives up the what long before anyone manages to explain the why, and Thacker Pass sat in exactly that gap for the better part of a decade. Subscribe for more stories like this one.